Okay, you should have notes on, let's say, combinations of functions, and you should see sum, difference, product, and quotient. Okay, now this is not, it looks harder than what it really is. Basically, the first one is sum, and that means you're going to take your functions and you're going to add them together. This is going to tell you what to replace your variable with. Well, if it's just x, then you just use the original function. So basically, you're adding the functions together, you're combining like terms. And then the next one you see is difference. Okay, what you're going to do there is you're going to take f and g, whatever the names of your functions are, and you're going to subtract them and put your like terms together. Remember, if you subtract, for example, more than one thing, more than one term, you have to change the 3 to a -3 and the 2 to a +2. Basically, you're distributing a -1, so just change the signs. Now combine your like terms, -1x plus 2. Okay? And then on the next one, you have product, and all you're doing is taking function f and multiplying function f by function g. Remember, if you have exponents and you multiply them, you have to really just add them. So don't forget your exponent rules. And then the last one, you are going to divide. Didn't mean to do that. You're going to divide two functions, f divided by g. Keep in mind that if you have an x on the bottom, your domain has an exception. X can be anything but the number that makes the denominator 0. So x cannot equal 2. So there are restrictions on the domain if you have an x in the denominator. Okay, if you'll move on in your notes to example 1. It says evaluate f minus g of x. F minus g of x. Let's see if that's a little bit better. F minus g of x. So you are taking your function f, which is 7x minus 5, and you're subtracting g, which is 3 minus 2x squared. So when you do that, the 3 becomes a negative and the 2 becomes a positive. Now you're ready to combine like terms. Let's put it in descending order. 2x squared goes on in the front plus 7x, and you can put these like terms together, and that would be minus 8. So f minus g of x, that would be your answer. On the second part, f minus g of 4, well, we already know what f minus g is. We just did that. So all you have to do is replace x with 4. So 2 times 4 squared plus 7. Replace x with 4. And simplify. Do your exponent. 16 times 2 is 32. Plus 28 minus 8. That's going to be 60 minus 8, which is 52. So f minus g of 4 equals 52. Okay, and then let's look at example 2. On example 2, let's do a different color. On example 2, we're doing f plus g first. So f is x cubed, and g is the square root of x plus 1. There's nothing we can do to that, so we just basically leave it like it is. The domain for f plus g, let's think about it. What numbers can we plug in for x and get 0 or bigger? Well, if you're not sure, just set x plus 1 equal to 0 and solve it. So x could be negative 1 or bigger. So the domain has to be negative 1. And let me go back here. Let's do this. Domain is negative 1 all the way to positive infinity. Alright, now we're going to do f minus g. So we're basically going to take the same thing, but this time we're going to subtract. There's nothing we can do. The domain's going to be the same. Negative 1 to infinity. Okay, and then we're going to do f times g. That would be x cubed times the square root of x plus 1. Can't do anything with that, so the domain is still the same. X could be negative 1 all the way to positive infinity. Okay, the last one is a little bit different because you have an x in the denominator. So let's look at it. You're doing f divided by function f divided by function g. So you end up with x cubed divided by the square root of x plus 1. So the domain is a little bit different because now we can take the square root of 0 if it's in the numerator, but you cannot have a 0, the square root of 0, 0. You can't have 0 in the denominator. So x cannot equal negative 1 because that would give us 0. So we're going to say this time anything greater than negative 1. So we could write it like this. That means it's not equal to negative 1, but anything above negative 1 to positive infinity. So it changed the domain when the square root is in the denominator. Okay? Alright, and then the next thing that we talk about is the composition of functions, and it goes into f of g and all of that. There's a video that I want you to watch after we work example 3. Example 3 says f of x equals the square root of x plus 3, and g of x equals x squared. So what we're going to do is we're going to take, this does not mean times, we're going to take f of g, kind of looks like fog, of x. What that means is f of g of x. So basically, we're going to replace g of x with what it equals, and that equals x squared. So now, we're going to go to function f and replace the x with x squared. So if you look at function f up here, you're going to do the square root, and where you see x, you're going to put x squared. You're replacing x with x squared in function f plus 3. Now, the domain for that, is there any number that we could put in here and give us 0? And give us a negative, sorry. any negative you punch in there, you plug in, if you square it, it's going to be positive. So the domain here is negative infinity to positive infinity, because you can square any number and it end up being positive. Alright, and then the next example is g of f of x, or g of f of x. So what that means is I'm going to replace f of x by what it equals, which is the square root of x plus 3. And then I'm going to replace, in function g, I'm going to replace x with the square root of x plus 3. So the function g, where it says x, I'm going to replace with x plus 3 squared. Now what happens is the square root and square cancel out, and you end up with x plus 3. Okay? And if you look in your notes on the composition of functions, you have to look back at the inside function, and whatever the domain is of the inside function, you have to keep that. So even though it ends up with x plus 3 right here, you have to look at the inside one to figure out the domain. They both have to have it in common. So what that means is our domain for this function is going to be negative 3 to positive infinity, because you have to apply the domain to the inner function. And there's a video on common mistakes that you're going to watch, and then you're going to see some examples of a teacher working some of these functions. And I want you to copy those examples down that he goes over, and I'm going to check those to make sure that you copied them down and you understand them. I will also send all of this in Remind. I think I've already sent the mistakes one and the one you're going to watch.